So this should look familiar to you. This is compact bone, a histology slide of compact bone. And now I'm going to talk about some of the more detailed structures of compact bone. So in your bone, like the length of your bone, you have these units called osteons running the length of the bone. So this you can kind of tell, like, this is a circular unit, this is a circular unit, this is a circular unit. These are all called osteons. So these are the functional units of compact bone. And it's called compact bone because you can tell it's very compacted together, okay? So very dense and rigid. That's because bone, compact bone, this is a type of connective tissue. So again, there are fewer cells dispersed amongst abundant extracellular matrix. And the extracellular matrix of compact bone is primarily a calcium phosphate salt. It's a mineral salt. It's rigid. So that's what gives bone its rigid nature, is the extracellular matrix made up of calcium phosphate mineral salts, primarily. So again, each one of these units, right, if I ask, what is this unit called, you would say an osteon. Now, if you look closely, you can tell that there are these concentric circles around this central canal. So in the middle of each osteon, this is called a central canal or a haversian canal. So central canal, haversian canal, either of those works for me for identification purposes. In the central canal or haversian canal, this is where you find arteries, veins, and nerves running through bone. So bone, even though it's the most rigid of all the connective tissues, it is very highly vascularized. So bone heals much faster than, say, cartilage or even tendons made up of dense regular connective tissue. So bone heals relatively quickly because it's so vascularized. So central canal, this is where the nutrient and the nerve supply for the bone is located. So arteries, veins, blood vessels, and then the nerves. Okay, so this is the central canal. Now, radiating outward from the central canal, these concentric circles are called lamellae, right? So what happens is, so embedded in the lamellae, these little dark little, oval-shaped things, these are the osteocytes. Osteo meaning bone, and then cyte, cell. So each one of these guys is an osteocyte, and they're embedded within that lamellae. So these osteocytes start secreting and pumping out those calcium phosphate mineral salts, and then they enclose themselves in a little house called a lacuna, okay, which you heard me say lacuna with cartilage when I talked about the chondrocytes that are located in their little house called a lacunae, okay. So these guys that are embedded in those concentric circles, again, those are called lamellae. These are the osteocytes, the actual bone-producing cells, okay, and they're mature bone-producing cells. All right, but if you look, so these concentric circles are running in this direction around the central canal. With the osteocyte, if you look, there's these little tiny feather-like little projections, okay? Little tiny projections coming, and they're perpendicular to those concentric circles. So they're radiating out that way, okay? Those little channels that are coming off the osteocytes, they have a special name called canaliculi. So canaliculi, canal, and iculi is referring to the fact that they're little tiny canals, little tiny channels. So these canaliculi actually run and connect with other osteocytes. They also eventually connect with the haversian canal or the central canal. Okay, again, this is where you have the blood vessels and the nerve supply. So these canaliculi allow for diffusion of nutrients and waste between the central canal and the osteocytes. They also allow communication between the osteocytes because these little canals, these canaliculi, connect osteocytes to osteocytes as well as osteocytes to central canal. So that's how the diffusion of nutrients happens. Okay, those nutrients diffuse through those canaliculi to the osteocytes. Okay. So very highly vascularized, and that's how the osteocytes get their nutrients so quickly. And then waste products that are generated by those osteocytes would diffuse back through those canaliculi, eventually making its way back to the central canal. So you should be able to identify a central canal or Haversian canal. The entire unit is an osteon. The concentric circles are called lamellae. These cells are called osteocytes, and the little canals that are coming off of the osteocytes that connect osteocyte to osteocyte as well as osteocyte to central canal, those are called canaliculi. Now you'll notice that this central canal, there's larger canal, okay, that's coming off, and eventually, so if we were to be able to scan over here, you would see that this central canal is connected to another central canal. And it's connected through this structure right here called a Volkmann's canal, or perforating canal. I think your book may call it perforating canal, also called Volkmann's canal. And these are channels that connect central canal to other central canals, okay? And they run perpendicular to the length of the bone. So these are the structures of compact bone that you should be able to identify. We have compact bone plastic models, okay? This is showing you a general structure of a long bone. So long bones, this is like your humerus, your radius, ulna, metacarpals, phalanges, femur, tibia, fibula. Those are all examples of long bones, okay? So they have a long axis. They're longer than they are wide. Long bones, primarily making up the appendicular skeleton, so your limbs. You'll notice that the ends of the long bone are expanded. These expanded ends are called epiphyses. Okay, so this is an epiphysis. This is the humerus, and this would be the head of the humerus, which would fit into the shoulder, the shoulder socket, right? So this would be the proximal epiphysis. So each long bone will have a proximal epiphysis, again, using anatomical terminology, which you can't forget, which you learned day one in the class. Proximal epiphysis is the expanded end of the long bone that's closest to the trunk of the body. And then further away from the trunk of the body, this expanded end would be the distal epiphysis, okay? So expanded ends, these epiphyses, these create joints with other bones. Then this cylindrical portion that's in the center between the epiphyses, okay, this is the shaft of the long bone called the diaphysis. Diaphysis means shaft, okay? Now, running along the periphery of the bone, so they cut out this region here and expanded it so that you can tell more details. You can see that around the periphery, this is all your compact bone, right? You can even see the little osteons. So compact bone is around the periphery. Makes sense because around the peripheral edges of the bone, you want a really solid, rigid external part, right? Protection, and it gives you stability and all of that, okay? So compact bone around the periphery, but as you move in towards the center, you can see that it's not so compact. It's actually very porous. All of this is called spongy bone. So there are two types of bone, compact bone and spongy bone. Spongy because it's super porous. You can also see that there's lots of blood vessels running through this spongy bone. This is where you find red bone marrow. So this porous, spongy bone, this allows, well, one, it reduces the weight of the overall skeleton. You can think if all of your bones were made up of dense, compact bone, you would be super heavy and it would be really hard to walk around, right? So having this porous bone in the center allows us, it reduces the weight of the skeleton. It also provides spaces for blood vessels, red bone marrow, and it also helps, it gives a little bit of compression to these bones. So even though bones are pretty rigid and hard, they're actually pretty compressible, okay? So located inside of the epiphyses, this is where you find all that spongy bone, okay? And this is where you find the red bone marrow. Now, if you look in the diaphysis, okay, so this portion of the diaphysis has been expanded over here, you can see that the middle of the diaphysis is actually hollowed out. So there's still compact bone around the periphery, but the inside has been hollowed out. And that hollowed out center is called the medullary cavity, okay? So it's called the medullary cavity. Located in the medullary cavity is yellow bone marrow. So yellow bone marrow is actually, think of it as like almost like an adipose in nature, and this is for like extreme energy. Like in cases of extreme starvation, we can use yellow bone marrow for energy production. Okay, so the hollowed out center of the diaphysis is called the medullary cavity, and this is where we find yellow bone marrow in cases of extreme starvation for energy. Red bone marrow actually produces all of your blood cells. Red and white blood cells, okay, are produced in the red bone marrow. Okay, and actually this yellow bone marrow can convert to red bone marrow if needed, if you're really low blood volume, all of that. So this is another image of, again, this is an example of the expanded end of a long bone called the epiphysis. This is the shaft called the diaphysis. Where the epiphysis narrows into the diaphysis, this region is called the metaphysis. I'm not going to ask metaphysis, but you should know epiphysis and diaphysis, okay? Epiphyses are the expanded ends that create articulations or joints, and then the diaphyses are the shafts. Now, what I want to point out here is that in between the epiphysis and the diaphysis this is the growth plate, also called the epiphyseal plate. This epiphyseal plate is made up of hyaline cartilage. This is what allows your long bones to grow and to elongate. When you grow, right? You grow taller as you go from child to adult. How do you grow taller? These growth plates, these epiphyseal plates, are made up of hyaline cartilage, and they can expand. Okay, so this is the epiphyseal plate. In an adult over 25 years of age, okay, growth rates are dependent upon woman versus male. Estrogens have a stronger effect on ossification. So ossification means like ossifying your cartilage into bone. Okay, so creating bone. Okay, rigid, hardened bone. But if you're an adult over 25 years of age, this epiphyseal plate will no longer be hyaline cartilage, but it will have been replaced with bone. Okay, and that's why you stop growing after a certain age, is because you don't have any more cartilage right here left. It's been replaced by bone. So again, epiphysis, diaphysis, epiphyseal plate in between. This is just a nice little diagram that shows you the difference between the axial and appendicular skeleton. So axial skeleton, this would be the skull, the bones of the cranium, and the facial skeleton. Your vertebrae, your sternum, your ribs, okay? This is all axial skeleton, okay, the axis of the body. And then the bones in red are all appendicular skeleton. So your shoulder girdle, which is your clavicles and your scapulae. Your arms, which is your humerus, radius, ulna, and bones of the wrist and hands. Your pelvic girdle, which are your coxal bones, or os coxae. Your femur, tibia, fibula, patella, bones of the ankle and feet. Okay, so now you are going to need to know all of these bones and structures of these bones, and I've posted that in a PowerPoint, in a PDF file. It tells you each PowerPoint slide has bones listed, and underneath each heading, each bone title has everything you should be able to identify from those bones. What I suggest doing is getting your lecture book out, opening up to chapter 7 where it starts bones, and you go through and you highlight all of the structures that I have listed on that PowerPoint. You highlight those structures, and when you come to class, now you know you can open up your book, you have everything highlighted, you've already looked at it, you've already watched my videos. I have videos posted of every single bone, and you can just pick out the bones from the cabinet and start identifying it. Okay, and then I'll be there to help. So highlight those structures in your book and come prepared.